Hi, you're welcome to Explore Insights. In this video, I'd like to teach you on Excess-3 code subtraction using the 9's complement form. Now, prior to this video, I've made an explanation on Excess-3 code and Excess-3 code addition. So if you would like to watch that, please watch my previous videos. Now, without any further ado, let's get started on case 1. Now, in this case 1, I'll be treating the subtraction of large number from small number. Now, if you're interested in the subtraction of small number from large number, which is the case 2, please look forward to watching my subsequent video on that. Now, let's go through the step. So I just have 4 steps to explain how this works. Now, the step 1 is to take the 9th complement and the Excess-3 code for the superhand. And whatever we have in that value, we're going to add it to the minor end Excess-3 code. Now, for that, we are going to step 3, which tells us that we have to check if carry is generated. And if it's generated, we have to shift the carry to the next bit. Now, the fourth one is we're going to add 3 to the carry generated bits and subtract 3 from the other bits without carry generated. If end carry is not generated, then we'll take 9th complement again. I understand. Maybe you see this being complex, right? Don't worry, I'm going to digest that with an example. So let's proceed with an example. So in this part, we are asked to find the 9th complement Excess-3 code subtraction of 573.13 from 132.51. Now, we are going to proceed with the step 1, and the step 1 requires us to find the 9th complement of the superhand. So first, it's good to identify the minor end and the superhand, like I usually say in all of my videos, because that is very, very important. Okay, so now we can see that 132.51 becomes the minor end, whereas 573.13 is the superhand. Now you can see that we are actually dealing with the subtraction of large numbers from small number. Okay, so to that, we're going to look at the 9th complement of the superhand, and based on the number of the bits, we are going to spread that out. So we have 5 bits. It means we are going to put up 5 nines. Yes, so to that we have 9's. So 9 minus 3 will be 6, 9 minus 1 will be 8, 9 minus 3 will be 6, 9 minus 7 will be 2, 9 minus 5 will be 4. So having gotten this, step 2 says that you're going to find the Excess-3 of that value you've gotten from the 9th complement of the superhand. So to that, I'm going to add 3 each to each of those values. So it means I'm adding 3 here, 3, 3, 3 for each of the digits. Now it's going to give me 6.39, 8 plus 3, 11, 6 plus 3, 9, 2 plus 3, 5, 4 plus 3, 7. So we've gotten the Excess-3 for this 9th complement of the superhand. So let's proceed with the second step. So for the second step, we are to add that value gotten from the 9th complement Excess-3 code of the superhand to the minor Excess-3 code. So first of all, let's solve the minor Excess-3 code. Now we have 132.51 as the minor end. So we are going to check the Excess-3 code. So we are adding 3 to each of those digits. So we are having 1 plus 3, 4, 5 plus 3, 8, 2 plus 3, 5, 3 plus 3, 6, 1 plus 3, 4. So with that, the minor Excess-3 code will be 465.84. Now let's go on with the addition of what we have gotten for the 9th complement of the Excess-3 code of the superhand and the minor Excess-3 code. So this is what we are going to have. So previously in my other sheet, I told you the summation for this to be 759.119 and this to be 465.84. Now we're going to spread it under 8421. Okay, so let me take you through how I was able to get this. If you're just joining this video for the first time, if not, for those that started with me, I've already made you to understand how I used to get this value. So nevertheless, let me go on with the explanation. So, but pardon me as I go a bit less on this. So for us to get 9, it means I'm going to check 8421. What is going to sum up to get us 9? So we have 81, which is 9. So anyone that sums up to give us 9, I'm going to represent it as 1, while others will be 0. So this is the fastest way I use in solving this. Okay, so now 8 and 1 gave us 9, right? So I'm turning that on as 1001. Okay, so let's go to the next one, 11. So think mathematically, which of these values will sum up to give us 11? You can see that if I take the summation of 8, 2, and 1, I will have 11. So I'm turning that on. Since 4 was not inclusive, I'm taking that as 0. Now let's move over to 9. Just to replicate what we've done here, it will be 1001. Now moving over to 5, we could see that 4 plus 1 will give us 5. So this will be turned on while others will be off. So this is what we got here. Now for 7, what will sum up to give us 7? It means that the summation of 4, 2, and 1 will give us 7. So I will turn that on as 111, while 8 will be 0. Now let's proceed with 4 in this part. Now we can actually see 4 here. It means I will turn the 4 as 1, others will be 0. So we have 0, 1, 0, 0. Now for 8, I'm going to have 1, 0, 0, 0. So this is what I wrote down here. For 5, what will make up 5? Just like we've done here, it is 0, 1, 0, 1. For 6 is the summation of 4, 2. So that tells us that this will be turned on, the rest will be off, 0, 1, 1, 0. And for 4, we're going to have the same as 0, 1, 0, 0. So we are going to take the summation of these together. So that tells us that we're going to have 1 plus 0 as 1, 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 0, 1, 1 plus 0, 1, 0 plus 0, 0, 1 plus 1, 0, carry 1. Remember to put the dots at this point. So 1 plus 1, 0, carry 1, 0 plus 0 plus 1, 1, 0 plus 1, 1, 1 plus 0, 1. In this part, 1 plus 0, 1, 0 plus 1, 1, 1 plus 1, 0, carry 1, 1 plus 0 plus 0 will be 1. In this part, 1 plus 0, 1, 1 plus 0, 1, 1 plus 1, 0, carry 1, 0 plus 0 plus 1 will be 1. So having done that, we'll move to step 3. Now in step 3, we're going to say that if carry is generated, we need to shift it to the next bit. So we are going to look out for carry, if carry really exists. Now in my previous video, I made you to understand that carry, we have to know how many was the previous bit and the present bit. So that tells us if carry actually exists or not. Now in our previous bits here, individually we had 4. But in this part, we have 4, 4, 4, and here 5, and here 4 bits. So that tells us that carry actually exists here. Now, due to that existence, we are going to move that carry to the next bit, which is here. Now, we are going to retain this, retain this, retain this, but there will be a little modification here. So I'm moving this bit here, and when I do that, it means I'm sustaining this 0, 0, 1, 1, and I'm adding 1 here. If I add 1 here, I'm going to have 0 plus 1 to be 1. Why this no other addition is done, so we have 1, 1, 1. Okay, so having done this, let's move to step 4. In step 4, the rule says that you add 3 to the carry generated bits and subtract 3 from the other bits without carry. Okay, without carry generated. So sorry for that typo error. Okay, so I just made a little modification. Okay, so it said add 3 to the carry generated bits and subtract 3 from the other bits without carry generated. Now, I know this looks complex, but let me just quickly explain what it means. It tells us that where we had that carry generated, that part, we are going to add 3. Then that part, we don't have the bits generated. We are going to subtract 3 from it. Now, just look at this example. You're going to understand this very well. So this part was where carry was generated, right? So we are going to add 3 to this one and then subtract 3 from this ones. Now this is what you can see here. So this part is plus 3, but this part is minus 3, minus 3, minus 3, minus 3. Remember, you're using these new values, okay? These new values here. Now, if we subtract 3, for you to be very fast in your thinking, you can actually convert it to decimal so that you can know the value you're expecting. So in this part, if we say 8421, it means 8 plus 4 plus 1, that's 13 minus 3 is 10. And this is like 8 and 2. This tells us 10. So the same thing here. This one, 8421, this is, we are adding. So that's like, we are adding 2 plus 1, 3, and 3. So we are going to have 6, which is 4, 2. So this will give us 6. So the same thing, we subtract from here. If you subtract from here, this is 1 minus 1, 0, 1 minus 1, 0. So this part, 1 minus 0, 1, 1 minus 0, 1. So this is what we're going to have. And this literally tells us that we are trying to do 15 minus 3, which is 12, because 8 plus 4 is 12. We move over to this part where we are subtracting. We're going to have 8, because we are subtracting 8 plus 2 plus 1, which is 11, minus 3, which will be 8. Now in this part, similar to what we've done here, the same 8. So this is how we were able to get the answer here. And then we'll proceed. We will check if carry is generated. Now in this condition, we said that if carry is not generated, we'll check is carry generated. At this end, we are having 4 bits, right? So take a look at this. So it means that end carry is not generated, so the result is said to be negative, and in its 9th complement form, represented as, at this point, it will be negative sign, okay, because of end carry is not generated. Now we are going to take, because the end carry is not generated, this result is in negative and in its 9th complement form. Now for us to get the actual result, we are going to take the 9th complement again. So to that, we're going to take the 9th complement of these values. And when we take the 9th complement, so a quick way of doing that is just look at what we have here. Now, wherever you have 1, change it to 0. Wherever you have 0, change it to 1. That becomes the 9th complement. That's another fast way to do it in binary form. So this is how we were able to get. So for your 1010, we have 0101, 0110, 1001 for 9th complement. 1100 will be 0011 for 9th complement. 1000 will be 0111 for 9th complement. And this one, 1000 will be 0111 for 9th complement. Now to this, you can see that when we put this back in decimal form, I'm going to have this as 5, this will be 9, this will be 3, this will be 7, this will be 7. Maybe you're asking me how. Let me just explain. 8421, that is 4 plus 1, 5. 8421, what is relevant? 8 and 1 will be 9. 8421, 21 is relevant, 2 plus 1, 3. 8421, 421 is relevant, 7. 8421, 421 are relevant, 7. So remember, I said you need to keep the sign value out. So we are bringing it at this point. So this is why our answer will be minus 773.95. Now this is a very lengthy video, and thank you for staying up to this time. So remember, we talked about the Excess-3 Code Subtraction using the 9th complement. And this is case 1, where we talked about the subtraction of large number from small number. So do well to watch my next video. I'll be uploading also on case 2, where I will be treating the subtraction of small number from large number. Now, thank you for staying up to this time. I really appreciate your time. Do well to like and to subscribe if you haven't done so. Have a nice time. Bye.